In this video, I'm going to solve the problem 32 from chapter 19. Two containers are at the same temperature. The first contains the gas with the pressure P1 and the molecular mass M1 and RMS speed V(RMS)1. The second contains the gas with the pressure 1.5 times of P1 and the molecular mass M2 and the average speed V(average)2 equal to 2 times of V(RMS)1. Find the mass ratio M1 over M2. So here in this question, they mention two important information. The first one is the V(RMS) and the second one is V(average). We already studied the relation in the theory class. The V(RMS) relation is given by the rule V(RMS) is given by the rule square root of 3 times of RT over capsule. Likewise, we studied the relation for V(average), which is given by the rule square root of 8 RT over 5 times of capsule. So here the capsule stands for the molar mass, R is the gas constant, where T is the temperature. So in the question they clearly mention two containers have the same temperature. So let's take the first container has the rule for V(RMS) and the second container has the rule for V(average). So for both containers the temperatures are exactly same. So I'm not going to touch the temperature here. Clear? Okay. And then the most important thing, they mention here V(RMS)1 and as well as here they mention V(average)2. So for this, what I'm going to do, so wherever I just have 1, I'm going to consider this molar mass for this equation is 1, and here the molar mass for this equation is 2. Why? Because they mentioned this is V(average) of 2 and this one is V(RMS) of 1. For that reason, I just mentioned the molar mass here as 1 as well as 2. And we already studied the relation for molar mass in the theory. The molar mass is given by the rule M multiplied by Na, right? So now what I'm going to do, I'm going to substitute this relation here. If you substitute this relation here, your equation will become V(RMS)1, which is equal to square root of 3 times RT over M1 multiplied by Na. Likewise, if you substitute this molar mass here, this V(average) equation will become square root of 8 RT over 5 times of M2 multiplied by Na. So now I'm going to consider this is my first equation, this is my second equation. So now we are going to find the value of M1 over M2. For that, what I am going to do, I am going to divide the second equation by first equation. So what I'm going to do, I'm going to divide the second equation by the first equation. So first of all, I have to divide the left hand side of both equations and the right hand side I have to divide for both equations. So let's start. So first of all, I'm going to divide the left hand side. So what you will get? So 2 V(average) of 2 over V(RMS) of 1, which is equal to this part, square root of 8 RT over 5 times of M2 multiplied by Na, right? And here this is square root of 3 times RT over M1 Na, right? Okay. Now we are just going to squaring both sides because we have to discard this square root. So what I'm going to do, I'm going to squaring both left hand side and the right hand side for just to discard this square root. So the left hand side of the equation will become V square of average 1 over V(RMS) square 1. So this is V(average) of 2, right? Okay, which is equal to, when you square both left hand side and right hand side, what will happen? This square root will gone. So by that, this will become 8 RT over 5 times of M2 Na, and likewise in the denominator you will get 3 RT over M1 multiplied by Na, right? And now what I'm going to do, I'm going to substitute the value for this V(average). So we just go back to the question. You have to see here the V(RMS) 1 and V average of 2, which is equal to 2 times of VRMS 1. So what I'm going to do, I'm going to take this condition. So because we have to implement this condition in the equation, so what I'm going to do, I'm going to substitute V average of 2, which is equal to 2 times of VRMS 1. So I'm going to take this and I'm going to substitute here. If you substitute, what will happen? We have square here, so I have to square this one. So if you square this, what you will get? V square of average 2, which is equal to 4 times of VRMS 1 square, right? So let's we substitute the value here. So what will happen? 4 times of V square RMS 1 over V square RMS 1, which is equal to 8 RT over pi M2 NA multiply with this M1 NA will go to the top. So M1 NA over 3 times of RT. Now we can cancel this V square RMS 1, V square RMS 1 both in the top and the bottom. Likewise, we can cancel this Avogadro number, and here small n m1 stands for the molecular mass. So don't get confused about the caps m and the small m. Caps m stands for the molar mass and small m stands for a molecular mass. Clear? Okay. Now we can cancel this RT and RT here. So what is remaining? In the left hand side, we have 4 over 1, which is equal to 8 times of M1, right, over 3 times of pi M2. And here we are going to find the value of M1 over M2. So what I'm going to do, I'm going to separate M1 over M2 one side, and I'm going to move the rest of the term to the right side. So what will happen? M1 over M2, which is equal to 4 pi will go here, right? So already 4 here, we have 3 pi here. So when you multiply, you'll get 12 times of pi over, and this 8 will come here, right? Now we can cancel this. So this will go for 3 times, right? And this will go for 2 times. So what is remaining? 3 pi over 2. So therefore, M1 over M2, which is equal to 3 pi over 2, which is exactly equal to 4.712. So the ratio of M1 over M2 is exactly equal to 4.712. So this is the answer for this question. Clear? That's it. Thank you.